I've got a collection here of glow sticks. I know. Which colour should I use? Should I use green? I've got 2 beakers here at the front, one with hot water from the tap. I've also got another beaker here full of ice cubes and a bit of water, so I've got ice cold water. Part of chemistry, especially when you are employed to help an industrial process, you want to make it go as quickly as possible. Some reactions take forever to finish. For example, if you've got a piece of iron and you left it out in the salty ocean, it would take years for it to completely corrode. There are ways you can make it go faster. We want to figure out, does temperature affect how fast the reaction occurs? So I've got a glow stick here. Inside is a tiny bit of glass, and inside that piece of glass is actually the second ingredient. I've forgotten what they are, but when you mix the 2 chemicals together, then you get your chemical reaction, which actually creates the light. If the chemical reaction goes faster, what do you expect the glow stick to do?
Brighten very quickly.
It'll get brighter?
Yeah.
Yes.
What if it goes very slowly?
It'll slowly get brighter.
If the reaction is going very slowly, what will happen to the light?
It'll be dim.
It'll be dim? Alright, let's give it a try. I think these are already broken.
Yeah, you got ripped off.
I know. Just keep breaking them all. Here's one. Check it out. Glow stick. You can hear the glass inside cracking as I'm bending it.
How bend it? Wait, is that glass?
Yeah, there's a little bit of glass inside these. This is why you don't break them open. Also don't get it in your mouth. I think I bit it once when I was little and it actually tastes awful. Okay, so there's the colour. This is at room temperature. Observations?
Not super.
Patchy bright. It's almost bright.
Alright, let's try what happens when I put it in the hot water.
Yeah.
How hot is that? Is that like...
Almost scalding hot.
Oh yeah, it's bright. How hot is that?
How's that? Where I'm holding it, the bit where I'm holding it is still it's still at room temperature. The other end, where I've dipped it into the hot water, is actually what's been exposed to a temperature change. So what would you say? As the temperature increases, the reaction goes faster.
That's pretty cool.
Okay, let's try and see what happens when it goes to the water. He reckons it's going to stay the same.
Do the other side. Should we do the other side?
Other side?
Yeah, so we can do...
Okay.
Yeah, if you want to look, yeah, and then we can just re-snap it. Yeah, you get like re-snap it, and then you re-snap it to like...
Check that. So this side here, what my hand is touching, has been in the ice water. What happened to it? It looks like it's barely on at all. Let's try the other side.
Oh, look at that.
Alright, have a look now. Have a look now. When you go to the Acker and you buy a whole bunch of these glow sticks, or particularly at New Year's, you can use it all night long, but when you want to save it for another day, you can actually chuck it into the freezer. When you chuck it into the freezer, you can slow down the chemical reaction inside so slowly that if you wanted to use it again another day, you just take it out of the freezer and warm it up with your hands, and you should be able to get it to work again. But it won't last forever, because even though it's going slowly, it's still working. It's slowly reacting all of the reactants. Once all the reactants have been used up, it's going to stop creating colour. And you have one.
No.